in this video we're given a point, and we want to find the value of all 6 trig functions given this point. So on the right side I drew a picture of where the point would fall on our coordinate system, which would be in quadrant 4, and that's really all that matters. I did create a triangle given this point. I drew a ray coming out from 0, 0, and then drew a line here and there to make a right triangle. So then the values of this triangle will be x right there, this will be our y, and then the hypotenuse we'll say is r. Now we want to find r, and to find r we've got our formula of r equals x squared plus y squared, and we want to actually take the square root of all that, and that will give us our r. We could find then sine of theta, which is going to be, well, if we go off our angle right there, sine of theta is going to be opposite, which is y, over hypotenuse, which is r. So y over r, and there is our formula for sine of theta. And then we're also going to want to find the reciprocal function, so that's going to be cosecant of theta, and that's going to be r over y. And then we find cos of theta, doing the same thing. So adjacent over hypotenuse of this angle right here is going to be x, which is the adjacent, over r, which is the hypotenuse. Okay, and then the reciprocal function is secant of theta, so we could just flip over x and r, so that's going to be r over x. And then our last trig function, which is tangent, and that's going to be a tangent of theta, opposite over adjacent, so opposite of this angle is y over adjacent, which is x, so that's going to be y over x. And then the reciprocal function is cotangent of theta, which is going to be x over r. Oh, I'm sorry, that's going to be x over y. Now we have our x value, we've got our y value, and then we can plug those two into this function, or this formula right here to get our r, and then we can plug in the x, y, and r's into all these 6 functions, and we can get the value of each one of the functions. Okay, so let's start with sine theta. So we will need to find r for this because r is in the denominator. So let's calculate that over to the right side here. So r is going to equal x squared, so we're going to take 4 and square that, plus we have y squared, so we want to take our y, which is -8, and we're going to square that, and then we want to take the square root of all that. So 4 squared is 16, plus -8 squared is 64. Okay, 16 plus 64 is going to be 80, and we still want to find the square root of that. Now we need to figure out if we could break down this bigger radical. So is there a perfect square that divides into 80? And that's going to be, yes, it's going to be 16. So 16 times what gives us 80? That's going to be 5. So the square root of 16 is 4 times, can't do anything with this square root of 5, so we just keep it. So this is going to be our r value, and that's going to be just as important as our x value here and our y value there. Okay, now we can fill everything in. So let's get some more room. I'll move this up. Whoops. Okay. Sine of theta is y, which was -8, over r, which we said was 4 times the square root of 5. Okay, so that's alright, but we have a radical in the denominator, which we can't have. So we have to multiply the bottom by the square root of 5 to get rid of that radical, and we multiply the top part by the square root of 5. So if we simplify a little bit, we know that negative 8 over 4, that reduces to be just negative 2. So let's do that reduction first. And then we have the square root of 5 up top. And then this was taken care of already. So now the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is just 5. So we could write that down there. And this is going to be our value of sine of theta. Okay. Now we need to do the same thing for, or very similar thing for cosecant of theta. That's the reciprocal function for sine. So let's just flip our original answer right here. We had cosecant is r over y. So our r is 4 times the square root of 5. And then our y is negative 8. So this one's a little bit easier because we could just reduce 4 over negative 8. And that's going to be negative square root of 5 over 2. Okay, 4 over negative 8 is just negative 1/2. So that's going to be your answer for cosecant. So let's come down here and do cosine of theta. Okay, so that's going to be x over r. So the x was negative 4. And our r was, I'm sorry, that was positive 4. Our r was 4 times the square root of 5. We want to get rid of the radical in the denominator again, so we multiply by the square root of 5. And then that will equal 4 over 4. That could just reduce to be 1 over 1, so that cancels out. And then square root of 5 times the square root of 5 on the bottom, that just becomes 5, and then we have the square root of 5 on top. So that's going to be cosine. Now we could go over and do secant, which is the reciprocal function for cosine, and that's going to be r over x, which is, like I said, the reciprocal of this right here. So r is 4 times the square root of 5 divided by 4. That was our x. 4 over 4 cancels out. So we're left with just the square root of 5, and that's secant. Okay, the last one, tangent of theta, that's y over x. So negative 8 over our x, which is 4. This one's a little bit easier, so we don't have to work with a radical. Negative 8 divided by 4 is negative 2, so that's what tangent of theta is. And then cotangent is the reciprocal function. So we're going to do x over y. So x was a positive 4 divided by our y, which was a negative 8. So that's going to be a negative 1/2, and that's the value of cotangent of theta. Okay, so just to kind of review, since we did a lot of stuff here, the first thing you have to do is take your x and your y, plug it into this formula up here to get your r. And then once you're done finding your r, you just plug everything into, all of these formulas, your y and your r, your x over r, and that gives you the value of all these trig functions. The thing you have to look out for, obviously, is that radical in the denominator. Sometimes you will have to rationalize to get rid of any radicals in the denominator. You might have to simplify a little bit by reducing and stuff like that, but that is the gist of those problems.